And we're recording right now, so we're live. And all that glitters is an activity that we are going to discuss some properties of matter, namely density. Our objectives were to understand and use the terms mass, volume, and density. We're going to use the density formula for calculations. And we should understand and identify intensive and extensive properties. So this is a review of the first bullet's review. All matter has the properties of mass and volume. Okay? And I'll tell you guys what to take down. So just listen up for now. So these two properties depend on how much matter is present. I will tell you what's right. So just hold on for a second and listen up. And then you can keep your head up. Thank you. So mass and volume are called extensive properties because it depends on the amount of matter. So if there's more matter, what will I have? Will I have more mass or more volume? Yeah. If I have more matter, I have more mass. If I put more air into the balloon, what happens to the volume? Heavier and bigger. So that's what they mean by an extensive properties. Okay? So I'm not going to have you guys take this down, but just listen up. That's not something we're going to see too much of in this class, but I think it's worth bringing up in case you guys go on to take other science classes. Moving forward. Density, and this is what you want to write down. You want to write the first two bullets right there. Density is the ratio of mass to volume. Now, I know that you guys talked about ratios in algebra and geometry. So you guys should be very aware of what a ratio is. I'll explain it a little more. And density is constant no matter how much of a substance we have, assuming we have the same phase of matter in similar conditions. Okay? So I'll pause it here so you guys can take this down. Since the ratio of mass and volume is constant, meaning it doesn't change, assuming we're in the same phase, we call it an intensive property. Intensive property because it's independent of how much matter we have, which is different from an extensive property because it does depend on how much matter we have. Okay? Any questions before we move on? Pretty basic stuff here. Quick question. Which weighs more? Pound of lead or a pound of feathers? Renee? What's that?
Feathers.
The feathers weighs more?
No, it's the same thing. It's each pound.
The same weight. They both weigh 1 pound.
Oh.
But it's okay. Which one? But what are we really getting at here? I think you're on the right track, Renee. So think about this. They both weigh 1 pound, but look at how little space the lead occupies compared to the feathers. So what we're really trying to get at, 1 pound of lead and 1 pound of feathers, so they have the same weight. They both weigh 1 pound. But which of the same mass occupies more volume, Renee? Which takes up more space? The feathers takes up a lot more space than the lead. So how we say that is feathers are, listen up, feathers are less dense. Feathers, because they occupy so much more volume, the same mass occupies more volume, it has to have a lower density. Make sense, guys? All right, so let's move on. Density. So this is something you guys are going to want to write down. Let's define my variables. D is density, M is mass, and V is volume. I know. Where did we get up with those? So I'll let you guys copy this down, and we'll explain it momentarily. So we defined our variables, and the density is equal to mass divided by volume. That's the ratio of mass to volume. So that's the formula. So if we know the mass and volume, we can take the mass, divide it by the volume, and the result is the density. That's why they have that ratio. So let's move on. You guys all know algebra. You guys all took algebra. It's okay. We'll do a little review. You can actually also get all of these other formulas. So if you want to find from density is equal to mass divided by volume, you can solve for mass. Mass is equal to density times volume. You can also solve for volume. Volume is equal to mass over density. You don't have to write that down. But what I do want you guys to write down is a little trick that Mr. Costa and I have come up with in order to help you guys do this. So this is the triangle graphic organizer. So I want you guys to copy this down in your notebooks right now, and then we'll explain how to use it. So if you guys, let's take a look. Let's see what happens. If we cover the variable d, we see that density is equal to mass over volume, right? If we cover the variable v, we have volume is equal to mass over density. And if we cover the variable m, m is equal to density times volume. So if it's above each other, you're dividing. If it's on the same side, you're multiplying. So we can get all of these different equations here from just that graphic organizer. So cover the variable you're solving for, and the equation is there. So write all of these down right now, and we're going to do a quick example, and then we are going to move on to our activity. Go. So let's do an example, or two or three. So I want you guys to write the question down. The questions, write the first question down, solve for the first one, then we'll go through it. Then write down the second one, then we'll go through it, and then let's go through the third one, and we'll go through that. I want you to write the entire thing down. So.